right, this is the first free response problem from review day 9. Given a table of heights different years for a tree. And it says first use the data to estimate h prime 6. So again, this is classic table problem. They want you to find the average rate of change here. So it's 11 minus 6 over 7 minus 5. Just make sure you're picking the interval where 6 is in between. And we're going to get 5 halves. Okay, so that's worth 1 point. And then they say using correct units, what's the meaning of this? And so we would say the tree is growing at a rate of 5 halves meters per year at t equals 6 years. Okay, years. And so what they're looking for there is that you understand it's the rate that the tree is growing, and you put meters per year on there. If you did all of that, give yourself another point. Okay. Explain why there must be one time where h prime equals 2. So this is when it says there must be something about the derivative, we must be talking about the mean value theorem. Now, they give you 2 to 10. And if you do from 2 to 10, you get 13.5 divided by 8. That doesn't equal 2. So then you start to wonder, like, well, maybe it isn't guaranteed, but they're asking us to say why it is, right? So there must be an interval somewhere where that has to happen. So you start kind of moving around and testing your intervals real quick. And what you're going to hopefully come to pretty quickly is the interval 3 to 5. So if I look at the average rate of change from 3 to 5, it's 6 minus 2 over 5 minus 3, which is 4 over 2, which equals 2. Okay, so the average rate of change between 3 and 5 is 2, and so therefore there must be a time in the interval 3 to 5 where h prime t equals 2. So that's what they're looking for. Did you find the derivative or the average rate of change from 3 to 5, and then did you conclude it through the mean value theorem? All right. You may want to say, therefore there must be a time in the interval where this, because h of t is differentiable. I'm not sure. That's just to be safe, because the mean value theorem has to have a continuous differentiable function. So it's always safest to say something like that. But they may have given you the point anyway. So you got a point for using this average value idea, and then you got a point for saying mean value theorem is y. Okay. All right, C says use a trapezoidal sum with 4 subintervals to approximate the average height. So this is key. You have to see that it's an average height from 2 to 10. So we'll do this down here. To find that average height, we're going to go 1 over 10 minus 2, so 8 times the integral from 2 to 10 of h of t dt. And we're going to say that that's approximately 1/8 times. Now we're going from 2 to 3, so we're going to add this together. That's going to be 3.5 times the distance between them, which is 1, divided by 2. Plus, then we're going to add up the other ones. 2 plus 6 is 8 times the distance between them divided by 2. Plus, add up the others, 17 times 2 divided by 2. And then finally, the other ones is 26 times 3 divided by 2. All right, so this is what it equals. And if you left it like this, I believe you'd get full credit, because that is technically the answer. They gave 1 point for the trapezoidal sum and 1 point for the approximation. So I think knowing that the 1/8 was supposed to go there gives you a point, and then all of that gives you a point. If you're just kind of curious, it does work out to 263.30 seconds, but I don't know if that's worth your time on the AP. As soon as I saw that 3.5 divided by 2, I kind of felt like maybe I should just leave this. Some of these are going to be easy. Like that'll be 17, that'll be 8, this will be 39. But that's the one that'll throw you off. And then you got to divide by 8 at the end. So probably not worth your time, right? So then we get to D. And D says the height of the tree can also be given by this function here, where x is the diameter of the base of the tree. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. According to this model, what's the rate of change of the height of the tree with respect to time? So g is acting as the height. If it helps you, you can put an h there instead, or whatever would kind of help you see this. So this is a related rates problem. What they want you to do is to take the derivative of both sides, but they also want you to do it with respect to time. So for part D here, we're going to go dg dt. The change in height over change in time is, and we have to use a quotient rule. So we're going to go 1 plus x times the derivative of the top, which is 100 times dx dt, minus 100x times derivative of the bottom, dx dt, over bottom squared. Okay, so that gives us our derivative, and that was worth 2 points. So doing the quotient rule correctly for this got you 2 of those points. Then what we want to do is plug our information in. So we're saying that when the tree is 50 meters tall, so that 50 is going in for our height. The diameter of the tree is 0.03, is going at 0.03. So we want to actually put 0.03 in for our dx dt's. All right. Our x values are going to be 1, and the reason for that is we have to actually solve it. So that's a little sneaky. You have to put 50 in here and then solve that for x. So when height is 50, what does x equal? And again, in a case like that, you could just try to throw some numbers in real quick and see if you get lucky, or you can go through the procedure of trying to solve it. But we're going to get x equal 1 for that. So down here we've got our derivative. We're putting 1 in for x, so that's going to give us 2 times 100 times dx dt, which is 0.03, minus 100 times 1 times 0.03 divided by 2 squared. And this gives us 200 times 0.0, so that's 6 minus 3 over 4, which gives us 3/4 meters per year. And if you have that, that's worth a point. Okay, so that was a tricky one for sure. The equation is so weird. It sometimes, x can be seen as the height when really it's the width, and so don't get yourself too thrown off if D was a beast for you.